Hi, friends. How's everybody doing? Hope you have a wonderful week this week. The focus of this week will be twofold. We're going to talk about parallel circuits, which we've sort of talked about a little bit already, but we're going to put some math to it. And we're also going to talk about how to VERP it, which is just a problem solving strategy. Okay, so before we get started today, I've got two videos. This is the first of the two videos, and I want to give you a quick joke. How much did Santa's sleigh cost? Nothing. It was on the house. Jokes are great still, I know. Okay, so here's what I'd like to do. I want to go bring you back to PhET, like I showed you the other day. I really like this because it kind of gives you a conceptual idea of what's going on. All right, so what I have here is set up a parallel circuit. You can tell it's a parallel circuit because there's multiple different paths that you could take from one side of the battery to the other. I always think about this as like checkout lanes at the grocery store. Okay. You can tell that these are different resistors, right? Because again, they have the different color patterns, which don't really matter to you, but I just want you to know that they are different. Now, if I show the current, you'll see that the current is definitely moving differently through these resistors. And I'm hoping that you'll notice here, the current is moving really fast. Okay, so current always takes the path of least resistance, or you can say that it's lazy. So more of these are going to go down the one with the lowest resistance. Okay, so this one here, since the current is flowing the fastest, must have the lowest resistance. This one, the current is sort of flowing meh, and this one, the current is flowing really slow. So if I take a look and instead of showing the current, if I put the values on the resistors, you could see that we were right. This one is 5 or really small, medium, and large. Okay, so again, it's really important when we're talking about a parallel circuit to know that current takes the path of least resistance, or the lower the resistance, more current. Okay, so just like we did last time, what I'd like to do is I'd like to check and see what happens to the current, okay, as we go down each piece. Okay, so if I take a look at the current here, I get a value of 2.43 amps. And what that is reading is the total current because none of the current has gone down any of the branches. This spot here should also read the total current, 2.53 amps, because again, all of it has gone down the branches and it's heading out the exit of Wegmans, if you will. Okay, now if I take a look how much goes down each branch, you should see that the current here is 1.8 amps. That should be the highest current because again, we said this has the lowest resistance. This one is 0.45 amps. And this one is 0.1 amps. So unlike a series circuit, in a parallel circuit, the current does not stay the same. But what it does instead is it adds up. So I bet if we took 0.18 plus 0.45 plus 0.18 or 1.8, excuse me, I bet we'd get a total of 2.43 amps. So in a parallel circuit, it's the current that adds. What added in a series circuit? Do you remember? I hope you're all saying the voltage. Okay, so here's our voltmeter. What are the chances that I put this on the right way? Aha, good. Okay, so this is great. So the battery, the voltage of the battery or the total voltage is 9 volts. Good news. Okay, now let's figure out what's the voltage in each individual piece. Okay, the voltage here, 9 volts. The voltage here, 9 volts. Okay, would you be surprised to know that the voltage here is also 9 volts? Okay, so what's cool in a parallel circuit is the voltage is the same. Okay, so let's recap. In a parallel circuit, the voltage is the same, but the current adds up. In a series circuit, the current is the same, but the voltage adds up. Okay, so it's kind of the same, but kind of different. I hope you're saying to yourself, I wish we could learn some equations for this and write them in our notes and do some practice problems. Yes. All right. That is coming. Check out the next video. Bye, friends.